Okay, so section 10.1 is going to help us use sine and cosine and tangent with non-right triangles. So everything in chapter 7 dealt with right triangles or the unit circle. Chapter 7 is going to deal with non-right triangles. So the first rule we're going to talk about is the law of sines. The law of sines is a ratio between the angles and the sides opposite them. Capital letters or Greek letters represent the angles, lower letters represent the sides. And what you're doing is you're taking any pair of sides and angles and making a proportion to solve. So you can use A and B, you can use B and C, you can use A and C, doesn't really matter. How many possible triangles? Now, most of the time there's only going to be one, but once in a while, if A, so the side across from one of the angles we're talking about, is larger than that height, if it's less than B, we could have this triangle here, or we could have this triangle here. If A is greater than B, it's always just going to be the one triangle. I'll show you when that comes up how to tell, but we'll go from there. So for example 1, we're solving triangle in figure 7, that's this picture, to the nearest tenth. So round everything to the nearest tenth. So first we're going to look for what we know. Well, we know two angles, and a whole triangle has to add up to 180. So if we know the 50 and the 30, 50 plus 30 is 80, so we would subtract that, and we know that that angle is 100 degrees. Now we're going to figure out what ratio we know. So right now, alpha is across from that side, so that's one of our fractions. So we're going to do sine of 50 degrees over 10. So now that's one part of our proportion. So to find another missing angle, or side, we're going to use a different proportion. So this one's going to be sine of 30 degrees over C. Now, to solve a proportion, we cross multiply. So we would do 10 times sine 30 equals C times sine 50. And then to get C alone, we're going to divide both sides by sine 50. So we get C equals 10 times the sine of 30 divided by the sine of 50 degrees. If we type that in the calculator, first we want to make sure we're in degree mode because we're dealing with degrees. Then I'm going to type 10 times sine 30 degrees, close the parentheses, divide by sine 50 degrees, and I get 6.5 for C. Now to get B, we would do the same thing. Now we're just going for this pair. So I would keep the same original ratio. That way, if you made a mistake, you don't get them both wrong. And then make your new one. So the blue was sine 100 degrees over B. And then we're going to follow the same steps. Cross multiply. So 10 times sine 100 degrees is going to equal B times sine 50 degrees. Then we're going to divide both sides by sine 50 to get B alone. So 10 times sine 100 degrees divided by sine 50 degrees equals B. Then we're going to type that right in the calculator. 10 times sine 100, close parentheses, divided by sine 50. And if I round that, I would get 12.9. So that's going to give me 12.9 for this side. And now that I know all of the sides and angles, I've solved the triangle. So you go ahead and try the other one. So you can either pause the video and try it and then check, or just keep going. So if I do the you try, if I add 98 and 43, I get 141. If I do 180 minus 141, I get 39. So now I have all my degrees. One fraction I have is going to be sine 39 degrees over 22. And then depending on which side I want to go first, I can either do the A or the C. It does not matter. So I would say sine 43 over C. Cross multiply. Divide by that other value. And I get 22 sine 43 over sine 39 equals C. And if I type that in the calculator, I get C equals 23.8. Then if I do the other side, so we're still going to have our sine 39 over 22 equals, but this time it'll be sine 98 degrees over A. So then I'm going to cross multiply. So 22 times sine 98 degrees divided by sine 39 degrees gives me A. So A is 34.6. Now the whole triangle is solved. All right. What happens if we're going the other way and we need to find some angles? So we're going to do the same thing. We're just going to work in reverse. So find a pattern we know, or a pair that we know. So for that pair, it's sine 35 over 6. And then pick a pair you don't. Well, this side we have one piece, so this is a good pair to start with. Otherwise, if we chose the other one, if we chose this, we don't know the angle or the side, so that's not really helpful. So we're going to start with the blue. So sine of beta, because we don't know, over 8. We're still going to cross multiply. So we're going to do 6 times sine beta equals 8 times sine 35. This time we're going to divide both sides by 6. So we get sine beta equals 8 sine 35 over 6. Then if I put that in the calculator, so 8 sine 35 divided by 6 gives me that sine of beta equals 0.7648. 7648. And then to undo sine, we do the inverse. So that's the negative sine to the negative 1 of that. So you do second sine and then type 0.7648. Help if I type the right thing. And I get beta equals 49.9 degrees. So now that I know that this is 49.9, I can find the third side, the third angle of the triangle, by doing 180 minus 35 minus 49.9, which gives me 95.1. And then I repeat to find the missing side over here. So I would have sine of 35 over 6 equals sine of 95.1 over x. Now we know two angles, so it's just like we were doing on the other side. 6 times sine of 95.1 divided by sine 35, and I type that right in the calculator. 6 95.1 divided by sine 35, and I get 10.4 for that other side. So you can either do the you try on your own, pause the video and try it, and then come back, or you can just keep going. So if we did that, I'm going to draw the triangle. So we have alpha, beta, or I guess beta's down here, alpha, beta, gamma, or ABC. So they tell us alpha is 80. They tell us A, which is always across from alpha, is 120. They tell us B, so that's across from the beta, is going to be 121. And then here's if there's more than one. So if we look at A and B, A is less than B. So if we go back to those rules, when A is less than B, we could have two triangles. So one triangle will look like this, where beta is acute. And one triangle will look like this, where beta is obtuse. And I'll show you how to do the difference in those. So first, we're going to start the same way. We're going to have sine 80 over 120. And that's going to equal sine beta over 121. Then we're going to do our cross multiplying. So 121 times sine 80 divided by 120 is going to give us sine beta. If I type that in the calculator, 121 sine 80 divided by 120 gives us sine beta equals 0.993. Then I do inverse sine 0.993, and I get beta equals 83.2 degrees. So for our acute triangle, it's 83.2. Because sine is positive, this is a positive number, in quadrants 1 and 2, we also know we can have that other angle. So to find that, remember with our quadrants, this is between 0 and 180. We're just going to do 180 minus 83.2, and that gives us 96.8. So that means for our other triangle, beta can be 96.8. And then, so we start by finding the first one, just like that. And then to get the obtuse one, we do 180 minus whatever we got. Then we're going to go back and solve these just like we were solving before. Once we know two angles, we can find the third. So 180 minus 80 minus 83.2 is 16.8. So for that one, I would do sine of 80 over 120 equals sine of 16.8 over c. So c is going to equal 120 times sine 16.8 divided by sine 80. Oops. Okay, 120 sine 16.8 divided by sine 80 gives us 35.2. So in this triangle, we have 35.2. So that would be one possible solution. The other is we use that 96.8 that time. So we do 180 minus 80 minus 96.8. And we get 3.2. So for that one, we have sine 80 over 120 equals sine 3.2 over c. So 120 times sine 3.2 divided by sine 80. Don't forget to close your parentheses. And you get c equals 6.8. So that would be the other triangle. All right, so why don't you, that was the you try. All right, so now example 3 has us solving for the unknown side and angle around your answers. So what do we know? Well, there's one pair that's across from each other. So right off, we have sine 85 over 12. Now, the other pair that we know, so there's one pair there in green, and there's one pair there in like the maroon. The maroon doesn't have any information, so we have to start with the green. So we're going to do sine of beta over 9. So we would cross multiply. 9 times sine 85 divided by 12 gives us sine beta, which means 9 sine 85 divided by 12. So 0.7471 equals sine beta. So then I do second sine 0.7471, and I get beta equals 48.3 degrees. So now we can find alpha, because we do 180 minus the original 85 minus 48.3, and I get 46.7. Once I know that, I can do sine of 85 over 12 equals sine of 46.7 over A. Cross multiply, I get 12 times sine 46.7 over sine 85. And that tells me that A equals 8.8. So now I have my completed triangle. So you can either watch or pause the video and try the next one on your own. But if we do that, you're given alpha, beta. So alpha, beta, gamma, I think. Alpha is 80. A is 100. B, lowercase b, means this is 10. This one, A is greater than B, right? 100 is greater than 10, so there's only one possibility. So A greater than B, only one. Now we just go through the steps. So one fraction is going to be sine of 80 over 100. The other fraction is going to be sine of beta over 10. Cross multiply. 10 times sine 80 over 100 is going to equal sine beta. So if we put that in the calculator, we get 0.0985 equals sine beta. And then second sign that, we get beta equals 5.7. So if we do 180 minus 80 minus 5.7, we get 94.3. And then we can set up our final fraction, sine 80 over 100 equals sine beta over 10. So 10, nope, I lied. That's the fraction we already did. This time we're going to do sine 94.3 over c. So 100 sine 94.3 over sine 80 gives us 101.3 for that final side. All right. We're not going to worry about this one and the number of triangles possible. That's out of the scope of what we're going to be talking about. But the last thing we're going to talk about in this section is the area of a triangle using sine. So if you know side, angle, side, so two sides and the angle in between, even if it's not a right triangle, you can find the area. So with a right triangle, area is 1/2 base times height. When it's not a right triangle, you're doing 1/2 multiply the two sides together times sine of the angle. Now, sine of 90 is 1. That's why we don't need to worry about it when it's a right triangle. So let me show you how it works. Find the area of the triangle with sides. A is 90, B is 52, and the angle in between is 102. So you could draw any old triangle, or you could draw it so that it kind of follows the same pattern with the ABC here. So A would be 90, B would be 52, and this angle's 102. Either way, we have side, angle, side, where the angle's in the middle. So our area is going to be 1/2 the first side times the second side times sine of the angle. Make sure your calculator's in degrees if you've changed it. So 1/2 times 52 times 90 times sine of 102. And you get the area is approximately 2,280, and it says nearest integer, so 89. So go ahead and try the other one. Alpha, A is 7.2, C is 3.4, beta is 42. Even though it's a different angle, it's the same process. Area equals 1/2 times side 1 times side 2 times sine of the angle. If you type that in, you get 8.2. And then this would be feet squared. So that's how you find that. That equation will be on the note sheet. And then don't worry about example 6 and 7. We're, again, not going to be doing that in the scope of this. So that is what you need to know from 10.1. Hope that helps.